Hello and welcome to today's panel discussion on jetting and dispensing. Jetting has continued to expand in recent years and is complemented by a growing range of different valve technologies to meet any viscosity of material. What are the current challenges and jetting dispensing technologies, and how do manufacturers implement a reliable dispensing strategy? This panel will discuss these matters, and I'm delighted to be joined by, to my extreme left, Dr. Michael Schneider from Vermees Microdispensing. Welcome.
Hello, thank you.
Okay, and then to my left here we have Wolfgang Heinecke from Micronic. Welcome, Wolfgang.
Hi, Trevor. Nice to meet you.
Super. So let's get started, gentlemen. Let's get straight in with my first question, which is I'll give to you, Michael. Tight line definition and avoiding splashes, etc., are key to dispensing. So how can valve technology assist in this goal?
Yeah, well, of course, it's very important that you get a very perfect dot without any splashing or satellites around it. Mm-hmm. So the one very important point is what kind of jetting valve you are using. We have jetting valves for low viscosity liquids and for another group for high viscosity liquids. Both use piezo drive, mm-hmm. But one is normally closed, which is the low viscosity valve, and it has less power, so we transfer less energy into the droplet, which is shot out of the nozzle insert, and then it's also less likely that you get splashes. And right. It's also very important the distance between the nozzle insert and the substrate. So the higher the distance, the more likely it is that you get splashes or satellites, because these satellites normally are formed in the air, because we don't shoot out balls in the air, but we shoot out strings. And then if the distance between the nozzle insert and substrate is rather large, then it's quite likely that the tail of the string will rip off, and then you get satellites next to a central dot.
Okay, so would you concur with that, Wolfgang? I mean, low viscosity, keep the viscosity as low as possible, that you're dispensing, and have the dispensing head not too, closer to the substrate.
Yeah, so we have the different application. I mean, if we are talking at Micronic about jetting, then we often talk about solar paste jetting. There we have a certain viscosity, and there we have an unpopulated board. There we have different challenges, because we can just fly very closely over the board. I think it's 0.5 millimeters where we are traveling, and there we are sucking all potential satellites. We are sucking away and having a filter box just next to the ejector. Right. And this is, but as you said, the challenges are there. If you have different viscosities, populated boards, then you need to have different valves, where we are also working with MS together.
Right. So just to clarify, I mean, at Micronic, you've got the My 500 series, My 700 series jetter, but you're only jetting solder paste out of that. You're not. Are you doing other materials?
We are also doing other materials, then not with the ejector, but with other valve suppliers. Mm-hmm. We have our own valves, which we are using, but we are also working together with Vermees or Marco, or you name it. So there are different ones. Advanjet is another one which we have historically been long together, but we have opened this, and we have now a third-party valve jet program, because our customers are approaching us to address different challenges with different viscosities, different materials, so that we open up the possibilities where we can place a My 700.
Okay. So my second question is then, how important is valve maintenance, and how often should the valve be cleaned? Do you have any sort of guidelines for that?
Well, for the maintenance, it depends what kind of valve you are using. We have piezo-based systems, and for piezo-based systems we have, depending again on the valve type, a certain number of shots and cycles. We recommend, for example, to do maintenance every 100 million or 200 million or 300 million for piezo-based systems. And we have a new jetting system which is not piezo-based, but it has a dynamic shockwave drive. It runs on air, and there we give a guarantee of 500 million shots. But the customer is not forced to do the maintenance after 500 million, it's just the guarantee. It will most probably last longer, and there the maintenance would just be a recalibration of the valve.
It seems an awful lot of shots, 500 million. Can you imagine that? I mean, that sounds like a huge number. I mean, just thinking about it, you don't have to clean these valves at the end of every...
Doesn't mean clean. This means maintenance.
Oh, maintenance. Okay.
Cleaning is something different of maintenance.
Okay.
Yeah, maintenance means that for a piezo valve, that the piezo stack inside the valve is replaced by a new one.
Okay.
Yes,
okay.
because piezo stacks get older with time. Mm-hmm. And for the cleaning is very important, because this you would do much more often.
Yeah.
And it depends on the actual process. So we cannot say you should clean every 24 hours, but every customer has to determine himself how to clean and when to clean. Yeah. And we provide the materials to clean it, little brushes, tweezers, holders, tool set to dismantle the valve and then clean it in ultrasonic baths. Right. And we also have made the valve in such a way that it's very easy and fast to dismantle them. With in the past, our older valves have screws, for example, and newer valve types, we have a bayonet system where you just turn a leverage and then you can take it out. The so-called fluid box. Fluid box means the parts which are in contact with the liquid. And then the customer just puts another fluid box on the valve within 1 minute and can continue. And another system doesn't even have a bayonet where you have to turn a leverage, but you just press it in and turn, and then you can take it out. There's another system to easily and quickly dismantle the valve.
I mean, Wolfgang, is it important when you come to cleaning these valves that you really want valves with as few parts as possible, so they can't go missing, you can't lose screws or any of this type of thing?
That's for sure. I mean, when we are talking to our customers, the maintenance, or not the maintenance, but the cleaning is always a crucial part. So I don't want, as you said, the less parts as possible and as less often as possible. But this is very much depending, as you said, on the application, on the material. And so customers are aware of that. And but yeah, we try to make it as easy as possible for the customers. So because the valves are there for jetting, right, or dispensing, and not for cleaning.
Okay, so let's talk about jetting valves. I mean, can they handle really low viscosity and high viscosity materials?
Yes.
I mean, for example, can they handle?
Yeah.
I think we talked about it earlier today, handling water, for example.
Yeah, well, our so-called high viscosity range, they can do high viscous materials and also low viscous materials. But we also have then low viscous valves for low viscous materials. And then you would say, well, if the high viscous valves, they can handle both, why do we need then in addition these valves which are designed for low viscous materials? And this is in fact a safety feature, because if you want to jet low viscous materials, you don't need as much power. And then we are using a little spring to close we have a tappet and a nozzle to push the tappet onto the nozzle in order to have it closed if there's no electricity. Okay. So this is then a safety feature in case of the low viscous valves, that they will automatically shut if there's a power cut, for example. But with the high viscous materials, even if they're open, nothing will splash out, because it's a high viscous material. And then we use the power of the piezo in order to drive the tappet down and have more power for jetting higher viscous materials.
Okay.
Yes.
Okay. So, Wolfgang, is jetting, I guess generally speaking, a faster application than using a needle valve or any other type of system?
Yes, I mean, for sure, jetting, we have the possibility, and there we are with the ejector. If we're talking about soda pads, then we do this on the fly. So we don't need to stop, go down, go up, but we do this on the fly, and this allows us these 1 million dots, what we are making with the My 700, and that's why it is a nice not for all applications, but a nice screen printer alternative
Yeah.
for the low mid volume, or what we see also here at SMT Connect, an increasing demand for add-on for the solder paste process, that I have a screen printer up front and then the jet printer afterwards, because with the small components, the upper ratio, I have problems to get all the paste out of my stencil. So there the My 700 allows you at any point, at any volume, in any mix. And this is giving us a huge advantage over a stop and go process, speed advantage.
Yeah, I think you're right. I mean, you know, the old saying is that 60 to 70% of the defects that emanate from the printer, but the vast majority of these so-called defects actually relate to missing paste or insufficient paste. Yeah. So having a jetter following the printer to make all these corrections, as it were, can make a lot of sense. You know.
Yeah. And we had now at just yesterday at a customer there, he was talking about the electrification of the car, that we have the batteries, higher powers, we need big components, but we also need small components. It should be as close as possible together, but there is real heat, and I cannot make it so close together. Nevertheless, they need to work with step stencil because of the different sizes of the component. And they were very much interested into the jet printing technology. If they can avoid step stencils, everybody is happy.
Well, that's the beauty of it. You can get volume. You can put the height, the volume into the using the jetter. Okay, coming back to you, Michael.
I can add something.
Yes,
for this jetting solder paste. At this show here, we got several requests from companies who want to do jetting to rework PCB boards, which are quite expensive nowadays, get more expensive, and then they want to do a rework. And for rework, this is just a few boards. Then jetting is a good application.
Right.
Yes?
Right. Absolutely. So. When jetting solder paste, what is the recommended paste types? Because you need to use a slightly finer paste when you're using a jetter.
Yeah, well, if you want, it depends on the dot size you want to achieve. Normally, you don't want too large dots. So for, say, 200 to 300, 400 micron, you would then need 6 or 7 solder paste type. If you want to go below 200, which is very difficult, then you would need to start right away with 7. Even we talk to some customers, they are talking about solder paste type 8 and 9.
Really?
First time I heard this, they want to do use solder paste type 9 and do dots below 100 micrometer, which we cannot do. Wow. But we see that our customers want always smaller. For us, a stable process is possible till about, say, 200 micron is still possible. If you go below, it gets very tricky. If you do bigger dots, which also exists, of course, 400, 500, 600 micron, then you would use solder paste type 5.
Yes.
Type 4, we have no customers doing this. So but it's used for screen printing, type 4, but not for jetting normally.
Yeah, I mean, Wolfgang, I mean, type 6 is the norm, I think, isn't it, for most of these jetting applications?
So for my 700, we have approximately, I would say, 30 pastes released, and we have then different ejectors for small dot, normal, and big dot ejector, and then we are typically a small dot, definitely minimum type 6, and then type 5 for standard, and we have even one type 4 paste, which is basically for this add-on process, where it makes sense, but this is then also linked to the big dot ejector. But the standard is T5 or T6.
T5 or T6, okay. Good. Okay, so my next question coming up is on how many axis rotation is recommended for the valve to access hard-to-reach components on the board. Now, this doesn't really apply to you because you're doing a straight down deposition of paste. So I'll give this question to Michael. and I notice you've got a robot on your
Yes,
your booth.
we are not selling robots. In fact, this is just for demonstration.
Right.
So our valves, you can shoot from any position, even upside down. It works, but it has to be tested each time if it works for this type of glue or solder paste. So in case of solder paste, at the moment, I don't remember an upside down process,
I was going to say,
which we
I don't
have.
think you're shooting many
But I got one request at this show. They want to try shoot upside down flux and also solder paste. If it works, I don't know, but we will try.
Why would you want to do that?
Because the PCB board comes out of the machine upside in this way, and they want to do it from the bottom up.
Interesting.
Why, I don't know, but this is what they want. The customer wants to do. But for activator, we shoot upside from the bottom up. Yeah, this works, and for UV glue, it also works. So
Also on components, or
on parts, yes. If you shoot upside down, because the process demands this, so they have no space from the top and have a bend or whatever, and need to shoot from the bottom up. So it works. We just have to pay attention, of course, that the distance is right, so that the material doesn't fall down in the machine. So you need the right distance.
Right.
Also, solar industry, they want also to shoot upside from the bottom up.
From the solar industry.
Solar industry.
Yeah.
Yes.
Okay. So Wolfgang, what challenges does miniaturization bring, and what are the best workarounds? You're getting to smaller dot sizes and smaller areas. Is there anything? Is that an issue for you? Because we're constantly getting challenged with smaller devices all the time.
Yes, so Michael just mentioned already that customers are already looking below 100, which is not possible at the jet printer. We are still at 210, 215, which is the smallest one. We are working on smaller, but it is getting, the smaller, the trickier. And we try to solve this. The jet printer allows to have any volume at any position. So this is helping us, and this is the challenge we see. Miniaturization is one for sure, but to combine this with then the big power connectors, big power components, which are meanwhile also on the PCB, this is where we see the huge advantage of the jet printer. The miniaturization is another challenge, but the smallest components we still can do today, so 01, 05, we can still handle with a My 700.
Right. Yeah, so I agree. I mean, the mixed components, so the big components next to the small ones, where you need much more volume, that's going to be more of a challenge, I guess. Yeah. Do you have any issues or workarounds with with miniaturization and
yeah, of course. Since the last years, customers want always smaller and faster. So fast and small is the future, and we are looking into ways how to fulfill the wish of our customers. Some of our customers even say they can jet smaller than we can do. They say secret. I don't know if it's true, but we have customers say they can jet 120 micron solder paste dots with our system. We cannot, but they say they can. And we have R&D projects also in place to see what we can do with 100 micron, also with an alternative technology, not with the current jetting process, but with some different technology. We'll see what comes out of this.
Yeah. Okay. So my final question is really related to the material, the solder paste, or whether it's a glue or an epoxy or whatever it is. How important is the transportation and storage of these materials? Because they can have a negative effect on the dispensing application. Do you want to talk about that?
Yeah, I mean, we have qualified paste where we say, okay, if we have then different challenges. If we are talking about Senju, for example, who is a long-time partner for us, they're saying, okay, if you have at room temperature, our customers can store the material for a certain period of time. But this is very much depending then on the type as well. Type 5, Type 6 is already different. The different suppliers. So, I don't know where to start in this point. So maybe you have additional information.
We always tell our customers you have to ask the supplier of the solder paste how you have to store them. Normally, of course, should be in a refrigerator for solder paste. And some manufacturers, they have solder paste which are not so sensitive, and then you can keep them, you take them out of the production, and you can continue using them for a week or 2 weeks, and not much happens, even if you don't put it in the refrigerator. But others, you use it once, it works, you put it in the refrigerator, and the next day already doesn't work anymore as it's supposed to do. So it depends on the solder paste.
That's right. I mean, the solder paste is affected by temperature and humidity in the room, and it can go off quite quickly.
And our customers, typically they're using the cartridge then over the day from Monday to Friday, and if the cartridge is gone, if the cartridge is still usable or there's still material left, then over the weekend they put it in the fridge, but during the week, seldom. Actually.
Yeah, I think the cartridge systems certainly offer a level of protection for the material as well. So that works.
So when you get started, you should not take the cartridge out of the refrigerator and immediately put it on the production line, but you have to give it a half an hour, 1 hour time to get up to room temperature. Yeah. Otherwise, it will also change.
Absolutely. Yes. No, I agree. I agree. Okay, gentlemen. Well, thank you for your insights today. It's been an interesting debate, and so I want to thank Dr. Michael Schneider here from Vermis Micro Dispensing, and of course Wolfgang Heinecke from Micronic. Thank you, gentlemen, and thank you to our audience for watching today.